This one is January 2023 paper. Unit 2, we'll discuss the MCQs from this unit. The first one, student measure the enthalpy change of a combustion of methanol. After burning 0.2 grams of methanol, the temperature increased by 16. The measured uncertainty in the thermometer is 0.5 for each reading. What is the percentage uncertainty in a temperature change? So because how a temperature change is measured, temperature change is T2 minus T1. So uncertainty in each reading is 0.5. Like when we measure T1, the uncertainty will be 0.5. When we measure T2, the uncertainty will be 0.5. So what is the total uncertainty? 0.5 plus 0.5, so total uncertainty is 1. Because if we need the percentage uncertainty, the percentage uncertainty is uncertainty divided by value recorded into 100. So uncertainty is 1 and the value which we record, that is 16 and multiplied by 100. So 1 into 100 divided by 16, that will be 6.3, or C will be the right answer. Because whenever uncertainty, always add even we are finding a difference of the quantities or addition. If we measure it twice, then uncertainty will be double. In part B, there's the same question. Student repeat the experiment but burn 0.3 grams of methanol and uses 75 cm cube of water in a copper calorimeter. What is the expected temperature? So we have the formula E is equals to Cm delta T, or delta T, the change in temperature, E divided by Cm is equals to delta T. So temperature change is directly proportional to energy released or the number of the moles, and temperature change is inversely proportional to the mass or the volume, because um, density is mass over volume. As a density of a water is like 1 grams per centimeter cube, so this will be 1 mass over volume. So for a mass of a water will be same as the volume of the water. So first, in the first part of experiment, we use ethanol is there, a 0.2 gram, and 50 cm cube is there. But now 75, and the number of the moles or the mass is, so first it was in the beginning the mass was 0.2, but now the mass is 0.3. So how much the mass is increased by factor? It will increase by factor 1.5. And how much the mass, how much the moles will change? As we change the mole, the energy will also change. Like first we use 0.2 grams, but now you are using 0.3 gram. So it means that moles are 1.5 times, or energy will be 1.5 times, because more moles, more energy release. And what about the mass? In the first, we use 50 cm cube, or we can say 50 grams of water, but then we use 75. So how many times? This is also increased by 1.5. So what is the relation of a temperature change and energy? If energy is increased by 1.5, temperature change will be 1.5 times. And what is the relation between temperature change and the mass? It is inverse. So if the mass has increased by 1.5, the temperature change will decrease by 1.5. So because of change in energy, it has increased by 1.5, and because of change in mass or the volume, it has decreased by 1.5. So means they both will cancel out. So we'll have the same temperature change as it was in the original experiment. That's why C will be the right answer. Is it clear, this one? Part B. So temperature change proportional to the moles which we use, and temperature change is inversely proportional to the mass or the volume of solution we use. Student calculated the enthalpy change of a combustion of methanol and is more exothermic than the data booklet value. Like he's getting a higher exothermic, like higher energy. So we have the formula E is equals to Cm delta T. So student value is higher, like this is higher. So what are the factors which can increase? If heat loss to the surrounding during a combustion, so the temperature change will be small. If temperature change is small, then the energy will get less. Incomplete combustion release less energy. So that also temperature change is small, energy release will be small. Like energy which is absorbed by the water to increase temperature will be smaller. Evaporation of the methanol. So if the like incomplete combustion or if ethanol does not burn completely. So if ethanol, like because not all the mass which we calculated burned, so as a result, the temperature change of the water will be smaller. So energy which we calculate, like our calculated value will be smaller. Use a molar mass of ethanol in the calculation, like use of the molar mass of ethanol in the calculation. Molar mass, what we use, because like C2H5OH. So we have E is equals to Cm delta T. So molar mass is how much? If you see carbon is 12 multiplied by 2 plus hydrogen is 1 into 6 plus oxygen is 16. So this will be 24 plus 6, 30 makes 46. So molar mass will be 46. And what is the original mass of ethanol which we burned? The original mass we only burned 0.2. So if a student use a higher mass, like if higher mass is burned, so it means more energy should be released. That's why D is the right answer. So if energy lost to the surrounding, our calculated value will be smaller. If incomplete combustion, calculated value will be smaller. Evaporation happens for the fuel. So the fuel means will not burn completely. The smaller amount of energy release or smaller value of enthalpy change will be there. But if we use like molar mass, like we use a greater mass of methanol, so means more mass is burned. That's why we get a higher value. Because how we'll get a higher value? Enthalpy change is energy divided by moles. So it will be energy and moles equal mass in gram divided by the molar mass. So the this will give us enthalpy change per mole. And this molar mass is divided other side in a numerator, it will be multiplied. So it will be E into molar mass divided by mass in gram. So if student use a higher, like a use of a molar mass of ethanol in the calculation, then as a result, what will happen? Like instead of using this mass, the student use a molar mass. So as a result, he will get a higher value because like more mass of a substance will be burned. Is it clear? Question 2. Which equation represent the standard enthalpy change of atomization? In atomization, we should produce atoms in a gaseous state. So this is, and 1 mole of atom in a gaseous. So we are producing 1 mole of atom in a gaseous state. So when 1 mole of an atom is produced from its gaseous state, we call that as atomization. And from the element, so here both are these two are twice the atomization. So A or B can be answered. But what is the state of a bromine at room temperature? It is liquid. So from a liquid, when we produce a bromine atom, 1 mole of atom, we call that as atomization. Here we are producing one bromine from the gaseous state because bromine does not exist as a gas, it exists as a liquid. So it should be producing 1 mole of atom in a gaseous state from element in the standard state. The enthalpy change of a reaction can be shown by calculation using bond enthalpy. So it's always bond breaking minus bond forming will give us the enthalpy change. So we have hydrogen 400. This is a bond breaking side. This one is a bond forming. So hydrogen, hydrogen 436, but it is half, so 436 divided by 2 or multiplied by 0.5. Plus chlorine, chlorine is 426 and half, sorry, 242 and half, because half mole is there. This will be the bond breaking minus the bond forming hydrogen chloride 431. So half 436, half 242, and minus the bond forming energy, which is 400. And so this will be, because this will be same as this is same as this, minus 431. Which compound has a London force only in intermolecular? They all have London force, but which has only London force? So the molecule should be non-polar molecule. Hydrogen fluoride, it will have a hydrogen bond, because when hydrogen bonded to most electronegative element, such as fluorine, nitrogen, or oxygen, they will hydrogen bond. Oxygen and fluorine, they will have, because the bonds are polar and the molecule is also polar, so they will have dipole force, and dipole induced dipole will be there. But and this will have hydrogen bond and dipole induced dipole. PF3, so bond, because they are not able to cancel out and the bond will be polar, so this will have dipole force and dipole induced. But in CF4, carbon tetrafluoride, in carbon tetrafluoride, because like they all cancel out the effect of each other. Bonds are polar, but the molecule will be non-polar, like like same concept as methane. The bonds are here mean methane bonds are non-polar and molecule is also non-polar. But here bonds can be polar, but the molecule overall they cancel out the net effect. So when we have a non-polar molecule, they always have dipole induced dipole force or the dispersion forces, London forces also we say. Which compound has an intermolecular hydrogen bonding? Hydrogen bonding is when hydrogen attached to most electronegative element directly attached with oxygen, with fluorine, and with nitrogen. Any three of them. Here, if you see, like nitrogen is attached with carbon, and then the carbon with carbon, three hydrogen are there. So hydrogen is not directly attached to nitrogen. Here also, carbon attached to fluorine, and then with the carbon there are CH3, CH3, CH3. In this one, O and H directly they are attached with each other, so they will have hydrogen. And in aldehyde, CHO means C double bonded with O and H. So hydrogen is not directly attached. So whenever hydrogen directly attached to fluorine, nitrogen, or oxygen, the molecule will have a hydrogen bonding. What is the sequence? So remember this boiling point graph. First, we will have like example for group 4, 5, 6. So usually what happens, the first one will have a high because of the hydrogen bond. Then they will have dipole force, and then dipole induced dipole forces increases. This is how the graph vary. So if we have HF, then this will be HCl, and it will be HBr, and then it will be HI. So HCl will be greater than HCl. Uh, the order is there because it's about decreasing the boiling point. So HCl should be the last, because like HF is there, then HI, then HBr, and at the last HCl. So B will be the right answer. And reason, they asked this reason as well. So the reason is, first one is having a hydrogen bond. The second one is having a dipole. The third one, dipole induced dipole. But dipole induced dipole forces increases as number of electron increase. So in hydrogen bromide or hydrogen iodide, even though dipole induced dipole forces are there, but why stronger? Because they have more electrons. Greater the number of electron, greater the dipole induced dipole forces. Which ion contain vanadium with the oxidation number of 4? So if we write VO4 plus 2, so each oxygen is minus 2. So vanadium should be plus 4, because like plus 4 minus 2, the net will be plus 2. So A will be the right answer. Why not B, C, or D? Like when we check option B, it is written VO2 with plus 1. So each oxygen is minus 2, 2 oxygen will be minus 4. And vanadium, because net is plus 1, so vanadium should be plus 5. So here vanadium is plus 5, here is plus 4. What about the third option, VO3 with a charge minus? So each oxygen is minus 2, 3 oxygen will be minus 6. So vanadium is plus 5 as well, because the net is minus 1. And the last one, VO4 with a charge minus 3. So each oxygen is minus 2, 4 will be minus 8. So vanadium should be plus 5. So rest all of them actually is plus 5 only. It is plus 4 in A. What is the formula of potassium manganate 7? So manganate means MnO4 with a charge minus 1, and potassium is K, which is having a valency of plus 1. So potassium manganate 7 KMnO4. So A will be the right. How we identify, because how the net charge is minus 1 on manganate, each manganate is plus 7, each oxygen minus 2, so 4 will be minus 8. So plus 7 minus 8 will give minus 1. And minus 1 and plus 1, so it will become KMnO4. Compound Q produce red color in the flame test. So if it is giving a red color, so this give an idea that it might be calcium might be there, strontium might be there, calcium brick red. And it give a white PPT with potassium sulfate in a compound. So we have potassium sulfate. When Q is added, it will give a white PPT. And sulfate for group 2, look, it cannot be group 1. Why it cannot be group 1? Because group 1 does not form the precipitate. So A and B are totally wrong. It cannot be A or it cannot be B. We are left with C and D. So if strontium nitrate or barium nitrate, because they will form their sulfate. And as we go down the group, the solubility of a sulfate decreases. Like at the top of the group, they are more soluble. Down the group, they are less soluble. So strontium and barium both will give the sulfate test, positive sulfate test. But what about the flame test? For a barium is there, which is the apple green flame color. So it cannot be barium. So we are left with strontium, so which is red. So group 1, 2 does not form precipitate. That's why this reaction is not possible for any group 1 or group 1, sorry, not 2. So this one is not possible for any group 1 compound or group 1 metal. So that's why A and B are wrong. And then these are forming precipitate, but the color, if it was a barium, it will be apple green, and so it is strontium. Which reaction produces more than one product? So whenever a reaction is there, when a metal is reacting with the water, it will give salt and hydrogen. But as we go down the group, so magnesium oxide is there. This will produce calcium chloride, metal plus water. It will give metal hydroxide plus hydrogen. And barium dissolves, so it will form barium hydroxide. That's why C is the right answer. Which equation shows a redox reaction that would not expect to occur based on the trend in reactivity of halogen? As we go down, the reactivity decreases. The more reactive halogen displaces the less reactive halogen from its compound. Means like fluorine can replace any of them. Iodine and astatine. Here what happened? Iodine replaces astatine. So means this reaction is possible. Bromine with chlorine, like because the more reactive, chlorine displaces bromine. This is also possible. Chlorine and iodine, chlorine replaces iodine. Fluoride and astatine replaces, so this is not possible. Because like more reactive can displace less reactive, but astatine is less reactive. So the fluorine, it cannot replace or displace the fluoride ion from its compound. A fixed amount of concentrated sulfuric acid is reacted separately with excess of 4 solid potassium halides, in which would the greatest number of moles of halide oxidize? So you just have to check the equation. How many moles of halide are being oxidized? So you just check 8 moles are there, 2 moles are there, 1 mole, 2 mole. Because a fixed amount of reacted separately, in which the greatest number of moles of halide has been oxidized. And you can also check from the products as well. Like here, bromine is there. This is iodine producing iodine molecules. 4 moles are being oxidized here. Question 3. Silver nitrate is in aqueous ethanol is separately 4 halogen. So which would form a silver halide precipitate in a shortest time? So it should be, because tertiary compounds can break down easily as compared to primary or secondary. So breakdown of halogen depends on the tertiary compound. And second thing, like when we talk about iodide and chloride, like chloride ion, as it can react from precipitate much faster as compared to that of iodide. So when we check, this is chlorine, this is also chlorine. Here also chlorine. C is iodide. So, but why C is not the rate of hydrolysis? When we talk about the rate of the iodide will break down much faster because the bond length, this will be a longer bond length, so it can break down easily. By mistake, I said chloride, but it should be iodide. Break down faster than bromide, and bromide break down faster than chloride. Now, when we want to check, so this is iodide, but the thing is, when we compare them, we have to compare that this is one factor which affects another factor is tertiary. Like tertiary break down much faster than secondary, and secondary break down much faster than primary. So which one is a tertiary? When we check, tertiary means like the one which is attached with a carbon, like the carbon which is attached with the halogen. So A is iodide, this is also iodide. But which iodide will break down faster? So this is a tertiary. How it's tertiary? Because carbon, iodine, and then CH3. So this will break down much faster as compared to this one is a primary. So first thing you will check like what kind of bond carbon iodine should break down, and then you will check the type. So it should be carbon iodine, and tertiary it will break down much faster. Question 14. We have halogen alkane is heated ethanolic potassium bromide. So as a result, how many alkene products are there? Whenever alcoholic substance, it will result in a formation of alkene, like elimination reaction. Then what could be the product? If we have CH3, CH2, then this will be H is removed from here, or Br is removed from here, and H is removed from here. So this will be CH double bond CH then CH2, and then CH3. This is a product which is formed. How many alkene products are possible here? So how we can identify how many alkene products are possible? Because this is one possibility, and with this possibility, like 1, 2, 3, 4, 5, so this is hex 3-ene. But this hex 3-ene, what are the two possible products? It will be cis, or you can also say Z hex 3-ene, or it will be trans, or E hex 3-ene. Another thing, so because it will form two geometrical ions. Another thing, what might happen when they break the bond? Maybe the bond break between these two. Like instead of here, the bond might break between these two. So it might be CH3, CH2, because like this is H and Br is there. So they might break the bond. So the double bond might be here with the second and third. That is another possibility. Then H will be there. Then CH2, CH2, 1, 2, 3, 4, CH3. So this might produce hex 2-ene. But this hex 2-ene can also have a geometrical isomer. It can be Z or it can be E. So means two isomers of geometrical isomer of hex 3-ene and two geometrical isomers of hex 2-ene are possible. That's why total number of the products which are possible are 4 here. Because whenever the double bond, like this is the main structure. This was CH3, CH2, CH, Br, then CH2, CH2, CH3. This is the main structure, like the structure of the halogen alkane. But what might happen? Bromine might be lost from here, and hydrogen might be lost from here, so it will produce hex 3-ene. But other possibility, bromine lost from here and hydrogen lost from this one. So this will produce hex 2-ene. And these hex 2-ene and 3-ene, because there's a double bond, so geometrical isomers are also possible, as the identical groups are not attached, like all same identical groups are not there. That's why it is 4 different structures are possible for this instead of 2. So you have to include the isomers as well, geometrical isomer. Which compound is least likely to have a prominent peak at 43? So you have to divide this into fragment. So this is CH3, C double bonded with O, CH2, CH3. So this will be 15. 12 plus 16 makes 28. This will be 14, and this will be 15. So any 28 plus 15. So that will be 43. So this can give 43. What about the second structure? CH3, CH2, NH, CH3. So this total mass is 15. 14 plus 1 make 15, and 14, and then 15. So 15 plus 14, 29. 29 plus 5, 44. So 43 is not there. And if we count from here, 15 plus 15, 30. 30 plus 15, 44. So this does not give 43. So this won't give 40, because we count from left, we check from left and from right and identify. If we check the third one, which is CH3, CH, and then CH3 means. So what are the possible? This will be 15. This will be 14. This will be 15. This will be 15. So 14 plus 15 plus 14, 29. 29 plus 15, that will make 44. And 15 plus 15, 30, 30 plus this is 13, sorry, not 14, because ch is there, by mistake I wrote 14. 15 plus 13, 28, 28 plus 30, so that will be 43. So this will give a 43 peak. And for this one, 15, 14, 14, 15. So when we check for the last one, 14 plus 14, 28, 28 plus 15. So that will be for, like, this will be 14 plus 15, 29. Yeah, when there's a branch, you have to include them as a fragment as well. Like CH3, CH is there, and then CH3 and CH3. Because what might happen, it might break like this, or it might break in this manner. So 29 plus 14, so that will also make 43. So the least likely which will not make 43 is B. Which compound has a peak of 3,415, 2,000 in an infrared spectrum of, refer to the data booklet. So you have to use a data booklet for this. Like using a data booklet, you have to identify which one it match with, like the type of the bonds. Like 3,415, which type of bond is this? 2,250, which bond is this? Using a data booklet, and then check, because like if it was a carboxylic acid, then C double bonded with O should be there, and OH should be there, and CO should be there. If ethyne is there, like alkyne is there, triple bond absorption. Alkene is there. So you have to refer the data booklet. Without a data booklet, you can not answer this. You have to use data booklet and identify, and from that you will conclude. Question 17, the distribution of energy for a sample of a gas is shown. Why does the distribution start at origin? Like why it is starting at this origin? So there is like no particle with zero energy. If we don't have particle, like they don't have energy. But if we have any, even one particle is there, so some molecules have no energy. That is wrong. If some molecules were having no energy, then the graph will start with somewhat here. All molecules possess some energy. All the molecules have energy, like some energy is always there. That's right. The temperature is 0 Kelvin. That does not give any indication. If it was 0 Kelvin, then energy, the kinetic energy should be zero for these molecules. Some molecules do not have energy to react. That is about activation energy. Those which are before, they don't react. But why does the distribution energy start at the zero origin, which shows that all molecules have energy? There is no molecule with zero energy. Otherwise, there was a molecule at zero energy, it will start with y-axis, from y-axis. Some of the gas is removed and then container is resealed. How does the new distribution? Look, area under the graph depends on the number of molecule. If you remove the molecule, the number of molecule will decrease. And now it is being cooled. The gas is removed and the container of a gas is cooled. So when we cool, the energy will, the peak will decrease, but the total area will also decrease here. Why total area is decreasing? As the number of the molecules are also decreasing. So because area under the graph gives us the number of molecule. As we remove some molecule, so the area under the graph will also decrease and it will shift towards the left hand side. So B will be the right answer. If you don't change the number of the molecules, then the area of the graph will not change. And if you do the experiment at high temperature, peak will decrease and it shift towards right. This is at a high temperature. If you reduce the temperature, peak will increase and it will shift towards the left hand side. So this was